Get rid of my face. Kind of pick up where we left off. All right. So you were here when I was asking people to help me out with the iClicker stuff. There's some issue going on with the frequency, and I don't know if it's just the way I have it set up on my computer. So I'll be troubleshooting that later today and tomorrow, so that we should have that working for Wednesday. So we will start kind of using those. I also know there's kind of a back order and a backlog, so I don't want to start using them if any people haven't had the opportunity to kind of physically get one. Other than that, homework assignment was kind of made available on Friday. We haven't covered all the material yet. Due date's still ways down the road, but I would suggest start to try to chip away. I think the first 6 questions or so are really just getting used to using the online kind of tools they have for graphing and things like that. So those, I would get those out of the way just to save yourself some time when you actually have to sit down with some of the questions that might be a little bit harder and take a little bit more work. Okay. But we'll kind of continue to move through materials so that you can answer more and more of those. Once we get to a point where I know that we can answer every question on that homework, I'll say that in class and be like, okay, this is kind of where the first homework ends in terms of content. Okay. Any questions from me before we kind of keep going? No questions? You guys having a good Monday? No? Yeah? It's too hot? All right, so we left off talking about production possibilities curves. I'll kind of wrap up a little bit of the conversation on them, and we'll really kind of jump into a new topic today. So we had these production possibilities curves, and I think I briefly mentioned at one point, we were thinking about this in terms of like 2 countries. So we had like and I'll move out of the way in a second, a really disjointed graph there, right? Like it was like sharp. But if we had enough countries or enough companies, right, we actually end up with something that looks like a lot more smooth, right? So when we look at an economy-wide production possibilities curve, we can't really tell that there's like these small kind of like slopes, right? It looks more continuous and kind of has a nice curve to it. So it might look something like this, right? So let's say we've got some type of technological change, right? Maybe this is the invention of, I don't know, computers or a new type of steel alloy or something. For certain goods, right? We're now with that new technology, even using the same number of labor hours, are going to be able to produce more. All right, so this is the idea that I think the example I gave last class was it took 100 labor hours to produce 1 computer. Well, as our technology improves, it takes way fewer, right? Maybe only 50 labor hours. Well, now I can produce with the same amount of labor in my country, more computers, right? So if we see a technology improvement, and let's say it's specific to only one good, right? So let's say this technology improvement made it so that we can make microchips better. And so my thing was originally, I was on this PPF1, this Production Possibilities Frontier 1. I got some boost in technology where I can make computers more efficiently. Well, now, if we think about where am I at in the y-axis, right? And remember what these represented? It was like, I don't know, here's wheat, and here was our computers. Well, this point was like the maximum number of computers we can make using all our resources. Well, after this technology change, with those same number of resources, I can be more efficient, and I can actually produce more computers, right? And so that's why we see the kind of increase on that y-axis, thinking about that y-axis being our computers where we saw this technology improvement. Now, it could be that, okay, we got the technology improvement in microchip production. What's that going to do for how many tons of wheat we can harvest? Well, let's think about this very rudimentary. I mean, there might be, some type of advantage to certain types of machinery that this microchip could have so that, go out and the combines might be a little more efficient. But let's just assume for a second that this new microchip doesn't help any agricultural machinery. So if we use all our resources, the total tons of wheat we can still harvest is exactly the same. So sometimes we see this technology improvement where, yeah, it's going to expand our production possibilities frontier on one axis, but it may not change it at all on the other. However, kind of notice the nice thing, as long as I'm producing some mix of these 2 goods, no matter where I was at on this original production possibilities frontier, after the technology change, I can like keep either one of these goods the same and like move to a higher point, right? So if I'm doing some mix of these goods, I can always get to a level now where I'm producing more total of each good. Right? With the exception of if I only produce wheat, I can't expand at all, right? And that's because this technology change didn't impact that good. Now, if we saw something, well, yeah, so I say here, right, like somewhere we can get to like kind of this higher point. Now, what if we have a technology change that affects everything? So when I say technology changes, could even be something like population growth, right? We just have more labor hours now, right? If my population goes up, I'm just going to have more labor hours, more resources to produce either good. Okay? So I saw something like population growth, right? We'd probably start out somewhere like this. Well, population growth, if I take those new labor hours and devote them only to wheat or only to computers, it doesn't matter either one. I have more labor hours. Even if technology doesn't improve, that higher population expands how much I can produce of either good. So we kind of see this more of like a shift in the entire curve, right? Before it was just one side of the curve shifting up. With population growth or a technology improvement that affects both goods, we might see this kind of more of a shift out in on both axes, right? Does that make sense? Any questions on that? So you can kind of see, here we go from a point where we're producing 70 computers and 200 tons of wheat to 80 computers and 250 tons of wheat. Right? We can expand how much we're producing. Now remember what we said last class. Let's say this was our original production possibilities frontier. Let's say there was no population growth. So ignore the second curve for a second. What would C have been without the population growth? It would have been a point that was unattainable or unreachable, right? Given our current resources, our current labor hours. So after we get an increase in population growth, potentially there's points that before were not feasible, right? We couldn't get to that point with our resources that we now can get to. So, I don't think it becomes a much more complex issue. But this very basic model kind of shows you like why having a higher population is a good thing, right? I mean, in the sense that it just gives you more resources, right? We think about resources as like, I don't know, gold and silver, and I played like way too many computer games, like there's always wood, gold, Maya. So you think of these like resources, physical, but really the biggest resource that most countries have is labor, right? And so increasing your population expands your production possibilities frontier, expands so that you can now produce at points where you're producing more of all goods. Okay? And we just a kind of review of last class, and this would be something that I might use like for an IQ question. I was hoping to use them today, and now I've got this issue going on, so we're not. But I might do something like this where we got 4 points, A, B, C, and D. We've got this production possibilities frontier, and I might ask which of these points are efficient. Right? Well, to be efficient means that we're using all of our resources. That was kind of the idea. We said that if we're using all our resources, we're at a point on that frontier or on that curve. And so A and B here will be points that are efficient. I could have asked you maybe a different question. What points are unattainable? That'd be point D. And at what point is which one of these points is inefficient? C, right? Because we're not using all our resources. Any questions on anything related to that? That kind of wraps up our production possibilities discussion. Okay, so kind of set up what we're going to be talking about the rest of the week. Probably we might get a little bit further on Friday, but I'm just happy if we get through this. So we've got the demand curve. We're going to talk about the law of demand, differences between movements on the demand curve and shifts in the demand curve. Same kind of thing for the supply curve. And then we're going to kind of combine the two and talk about, now that we understand things about supply and demand, how do we determine where equilibrium is? What does equilibrium represent in these markets? And what happens if we see changes to supply and demand? How would that impact equilibrium? So that's where we're going. So we'll set up some very basic things. We're going to start talking about markets, right? But there's really a market for anything, right? I was thinking, I'm hoping to incorporate some examples because it's a little bit outside of the norm. But when we think about a market, it doesn't just have to be the market for desks, right? Or some physically produced good. This could be the market for intellectual contributions. Could be the market for a vaccine, right? We can think about the supply and demand for a vaccine. So a market really can be anything where we have people that want to provide that good and people who want to consume that good. It's a market, right? So, and if anything, do you guys know what NFTs are? Have you heard of these? Yeah, it's like digital, like they really have no value. But as long as there's someone who's going to demand them and supply them, then you'll always have a market, right? So it's very interesting And we won't dive into the world of NFTs. If you know that world, it's not something we want to waste a whole lot of time on. So we've got these markets. We say a market is competitive if no one seller in that market and no one buyer has influence over the price. Right? You probably can think about, if I'm the only person who owns a specific good, I have a lot of control over the price, because if you want to get that good, right, and there's nobody else who has it, you're going to have to pay whatever price I want. Now, as long as there's other people, right, I don't have influence over the price, because if I'm trying to sell you this bottle of water for $10, right, because maybe I'm outside a stadium and I know that, it's all you got. Well, if there's another person a block away selling a bottle of water for $5, what are you going to do? Walk down the block and pay half as much, right? Because if someone's willing, if there's more people, they're always going to be competitive on the price. No one person can influence what price you pay. All right, the collection of people might influence. We'll get into ideas of like market power. What we're first going to start out with is competitive markets, where no one person has any influence over the price. The easiest way to think about this is there's always going to be other sellers and consumers of the good. So you're always going to be competing with each other to sell that good by offering the best price, right? So we have a perfectly competitive market, right? What we need to be true, and this is kind of where we start out, and we'll kind of go away from this moving down the road. But at first, we're going to have a perfectly competitive market where the good we're talking about is exactly the same. So like my bottle of water is a good example, because a bottle of water is a bottle of water, right? And I guess there's some differentiation in the product, right? Like some people like certain types more than others, but for the sake of what we're thinking about, it's the exact same type of water, packaged the exact same. And so all goods are the same. I kind of already mentioned, but we also have to have this property of no one has an influence over the price. You have to, as a member of this market, either a buyer or a seller, you have to take the price as given, right? And if you try to increase the price, we're not going to sell anything, because you're just going to go to the next producer and buy it from them. So this chapter, we're not following the book precisely, but in this idea of talking about markets, we're going to use perfectly competitive markets to start out. So we'll first start talking about demand in a perfectly competitive market. All right. So quantity demanded is going to be the amount or the quantity that an individual or a economy, depending on how large we're looking at, would consume of a good at a specific price, right? So at a specific or at a given price there is a really important kind of part of that definition. Because if the price is $10, the quantity demanded of a bottle of water might be relatively low, right? But if the price is $1, the quantity demanded would be significantly higher, right? So every single price, we're likely going to see a different quantity demanded. So the law of demand tells us that, and this is kind of intuitive, right? Some of these will seem very dumb, but the law of demand is that as the price decreases, the quantity demanded of a good goes up. Or I think you can say it the opposite, right? If the price is rising, the quantity demanded will fall. People will want to buy less. And this is just kind of, it seems intuitive, right? A lot of economics is intuitive, and then the more interesting parts are where we get some non-intuitive results. Okay, so we're going to start notating price with P and then quantity demanded with Q subscript D, right? So there's going to be an inverse relationship between these two things. As the price goes up, quantity demanded goes down. We're going to always use a linear relationship for this class. I might occasionally show you what would happen if we had a nonlinear relationship. So all I mean by that is instead of seeing kind of a linear relationship, we might see a nonlinear relationship. But it's always going to be an inverse relationship. As price goes up, quantity demanded is going to fall. So we'll assume that it's linear for now. We'll start to think about how can I come up with a demand curve? I kind of foreshadowed a little bit. It's going to look kind of like that linear line up there, but why? Right? So all we're really doing is we're going to take a demand schedule, something that we know is going to occur, right? So this demand schedule shows us maybe the quantity that's going to be demanded at different prices. So I use Zoolander for this example, right? Orange milk and frappuccinos. And you can think about if the price was $0, it doesn't matter. Even if the price is $0, there might be a limit to how much you want to consume of something, right? I mean, 12 seems actually ridiculous here. If I drank 12, of anything, I think I'm going to not be feeling very good. So at a price of 0, maybe the quantity demanded is 12. As the price goes up, people are going to want to buy fewer and fewer of this good, right? Once it gets up to like $6 here, I think I have, except for Zoom's in the way. So let me drag this over. Right? At a price of $6, nobody, right? I guess I'm using Zoolander here, but Zoolander is not willing to buy any of these, right? Price is too expensive. And the idea kind of makes sense. Like, let's just say you were living on a fixed income, if you want to think about it that way. I've only got so much money. If I want to spend all $10 on something, well, if it's $1, I can buy 10 of them. But if it's $10, I can only buy 1, right? So even if you want to think about it from like a budget constraint standpoint, right? I'm going to buy fewer of something as the price goes up. I was thinking about this today. Other examples of like things in everyday life. I only have my frame of reference. But have you guys heard of the buyer's market? It is my favorite store. So they get like Amazon returns. They like are in old Macy's in the mall, and everything's like greatly discounted. And I went there, and there's stuff called kinesio tape. Like if you ever hurt your elbow or shoulder, it's supposed to help. It's pretty expensive. Usually I go to Meyer and it's like $15. I buy like one roll. So I went there and they had them for like $3. So about like 5 of them, right? So if you see a lower price, it's just something that happens in everyday life. We typically see as the price goes down, people buy more of something. Okay. So this is our demand schedule. It has different combinations of price and quantity. Okay. I think I clicked off this one. There you go. All right. So I've got my demand schedule. What I'm going to do to graph my demand curve is put price on the y-axis and the quantity demanded on my x-axis. So when I draw this out for you, a lot of the times I'll just do something that looks like this. I won't write the words out. I'll write price and quantity. I think I've got a nice visual on the slides, but I like to do board work sometimes. So if I look at the very first price, it probably is easiest to go from, instead of the lowest price, the highest price. Right? So I'm going to start at the bottom of that table actually, and say when the price is $6, the quantity demanded is what? 0. Right? So here's the first point in my demand curve. Let's say I then go to the next price of $5. What's the quantity demanded? 2. So I would kind of like plot that point at a price of $5. Quantity demanded is 2. And then just keep going, right? So what? 4 and 4. And I plot out every single one of these points, and then I connect them. Right? So that's how I come up with my demand curve from a demand schedule. Right? And I think I've got a little visual here in the slides where, right? Oh, I started going backwards here. I plotted the first price of 0, quantity demanded was 12, and the second price of $1, quantity demanded was 10. Excuse me. I then just went through, plotted every single point that I had in my demand schedule, and then drew a line through those. Right? And I ended up with this nice kind of linear demand curve. Okay? Any questions on anything? I mean, even if it's like related to like graphing or anything like that. Okay with this? Now, where does this information come from? A lot of times it's going to be from like looking at sales, right? Like sales data, or it's going to be something that's like given to, it's going to be coming from somewhere, but usually like it's given to us, right? The data is given to us about how much was consumed at different prices, or at least the very least projections. Okay. So we've got kind of Zoolander's individual demand curve here. I know it's a little bit weird. We call it demand curve, even though it's linear. Like I said, in reality, it probably looks a little something more like that, but it keeps the math simple for us as we move forward to make everything linear. Okay, so if we have a line, right, we can actually represent that with a formula. Okay? So what is our demand equation going to look like? Well, if I look at this guy over here, anytime I see a line, think, how do they show it to you in math? It's y equals mx plus b usually, right? So this is how we're going to think about it, right? It's very similar, but a little different. What is our y variable here? That's just price. price, if we draw it as a line, is always going to have a point where it intersects the y-axis, right? So we're just going to call that point A. And we're going to add to that whatever the slope of our line is, multiplied by the x variable. Well, so we're going to call the slope B, and our x variable is quantity demanded. Right? So typically, we'll kind of shorthand that. Looks something like that. Okay. Let me help you guys. I don't need to move this. Okay. So I'm looking at this. What is the, well, first of all, what would the value of A be in our example? What is the value of A in our example? Yeah, right. You're just looking at the point where it intersects the x-axis. Sorry, not x-axis. Intersects the y-axis, right? Or the point where your x variable is 0, or quantity is 0. Well, if quantity is 0, 0 times anything is 0, and the price that we would have with quantity of 0 is basically whatever the price is you see on that. So here our A value would be 6. Now, I'm going to actually calculate the value of B. Well, what should the sign of B be? The downward sloping line. Yeah, so as our x variable, or as quantity goes up, we would have to, only way quantity would go up is if we see a lower price, right? So if Q is going up, we know that the price must be going down, so that value of B is going to be negative. Right? I think I have this here. Right, we're going to keep everything linear in this class for the semester, this course. A and B are going to be some values, and we can calculate those. I'll talk more about how we calculate the slope in a second. But the intercept is kind of easy one. It's that point where it intersects the y-axis, which would be when quantity is equal to 0. When quantity demand is equal to 0, we can plug that 0 into our equation. Whatever A is, that's going to be our intercept value. The slope is going to be how much the price would need to change for us to consume one more quantity. Or I think the way I have it said here, if we were going to consume one, fewer quantity, right, what would the price increase need to be? Right, so what's that change going to be? Okay. So if you think about our example, right, and you could do this, I'll use the one I had in the slide here. And did I make sure I'm okay, I am recording this. Okay. So I could do it the way we were doing with the production possibilities curve and just use the two endpoints, right, to figure out the slope of this curve, right, my rise over run. So if I'm trying to do that here, I'll move in a second. So this point was 12, I believe. Right? So we're doing a rise over run. So if we go from this point to this point, so we're going from a point of 6 on our y-axis to a place of 0. So I guess if we're thinking about here, and we want to put kind of a more mathematical kind of term to it. And then I divide that by how much is my x value changing when I'm going from 0 to 12. All right. So if I do that math, 6 over negative 12, my slope is going to be negative 1/2. Another way to think about this, I can get my eraser. Because we're using price and quantity, I could also think of the slope is going to be the price of the first point I'm looking at. I'll move out of the way in a second. Minus the price of the second point I'm looking at. And those 2 points, right? That's the probably easiest way is just to use those two intercepts. Because then you get some zeros in there. The math is a little easier. And then divided by wherever your quantity is at the first point, minus where your quantity is at the second. It kind of puts it in context of our price and quantity. Any questions? in any of that. No, we're getting a little bit more mathematical here. So good. So I clicked off the slides again. There you go. So we've got the demand equation. We just went through that, talked about slope. So now that we have the slope, and we said earlier the intercept was 6, I can plug in those values for A and B, and I've got my demand equation for orange mocha for frappuccinos from Zoom. Right? So easy enough. Hopefully easy enough. Oops. But now that we have this demand curve and demand equation, and I'm going to try to really link this idea throughout the whole semester. So the demand curve is really telling us how much someone's willing to pay. Right? So we also would call it kind of what you're willing to pay up to, right? Whatever that consumption of, whatever the consumption of that good benefits you. Right? So we kind of had this discussion, I think, on Friday about, I'm going to choose to do something as large as the marginal benefit, long as the marginal benefit is greater than or equal to the marginal cost. Well, here, right, what's the marginal cost? What's the price I'm paying? Right? So I'm willing to consume a good as long as the marginal benefit is greater than or equal to the price that I'm paying. Right? Now, the problem is we also talked about marginal benefits are declining, right? This was like the example I used of consuming beer after I mow the lawn, right? That first one has a lot higher value than the sixth one, right? And so, or the first car you buy is a lot higher marginal benefit than the second. Right? So we know that marginal benefit is declining. So we know that as people consume more of a good, right? This is an individual demand curve here. It's one person. As they consume more of the good, they're willing to pay a lower and lower price. Okay. So maybe for the very first, orange mocha frappuccino, the price that he was willing to pay was $5.50, right? And he was willing to pay that much because it must have been that the benefit, the marginal benefit of that first unit consumed was $5.50 or higher. But then would they have paid $5.50 to consume the third or the second unit? Well, no, in fact, to consume that second unit, they were only willing to pay $5. And the third unit, and kind of so on and so forth. So another way to think about this demand curve is it's really representing the marginal benefit at each quantity. Because someone would only consume something if the price was greater than or equal to the marginal benefit. So we think about this curve. I've got here, we'll use the numbers, right? So it's minus 0.5 times 20 demanded. What you can really think about is the price is actually reflecting. I'm only paying that, I'm only willing to pay that price if my marginal benefit is greater than or equal to that. So at each quantity, that price is actually reflecting how much that person, the additional benefit to that person, consuming that quantity of the good. So if I think about the price is representing marginal benefit, what's the marginal benefit of the second orange mocha frappuccino, the second unit consumed? Well, I would just plug a 2 in here, like the quantity of 2, the marginal benefit of that second unit consumed would be 2 times 0.5, which is 1, 6 minus that, so the marginal benefit when quantity is equal to 2, I would just plug that 2 in and get 5. Well, what's the marginal benefit of the fourth unit? We plug a 4 in here, 4 times 0.5 is 2, 6 minus 2, right? And that would be 4. So we're kind of linking these up, right? Here's the marginal benefit. I'll move out of the way for you guys. I'm behind me in a second, right? So the marginal benefit of that second unit consumed, right? I just plug the quantity 2, I got 5. The marginal benefit of that fourth unit consumed, I plug 4 in, and that would give me a marginal benefit of 4, right? So as I consume more of the goods, the marginal benefit is declining, which lines up with what we were talking about last class, right? So that price really reflects the price a person would be willing to pay. I'm only willing to pay it if it's greater than or equal to my marginal benefit. Okay. All right. So what I kind of just went through this with the different values, but could I find the marginal benefit of the first, second, and third unit consumed? Sure enough, pretty easy. I just plug those quantities into my demand equation, and the price that the demand equation spits out of me, that represents the marginal benefit of that unit consumed as well. Okay. Any questions on that?
This only works with linear though, right?
With what?
Like, you can only use that again.
So it would be a similar idea, just more complicated math if I wanted to find the marginal benefit with a nonlinear curve, right? It's not going to be near as simple, right? Because I'm going to have a squared term in there, and my marginal benefit is going to decline quicker, right? It won't be like 50-cent jumps. It would be the first jump is likely the way we think about it. It's going to be much larger, right? There's a much quicker decline initially. Like if I'm buying cars, the marginal benefit going from car 1 to car 2, huge drop. But then car 2 to car 3, it's not as much of a drop because kind of the cars aren't near as useful. So you get like this smoothing of the curve. Yeah. So it would be the numbers would play out a lot different, but it'd still be the same idea. That price would still reflect to you with the marginal benefit of consuming that universe. So if you want to put a term to this, the idea that marginal benefit is going to be declining as we consume more of something is the law of diminishing marginal returns or diminishing marginal benefit. So as we consume more of something, that marginal benefit is declining. And that's really what's kind of floating around behind the scenes of that law of demand. That's why we see quantity decline as we increase, or sorry, quantity increase as we decrease the price. Questions on that? All right. So we were just talking about one individual's demand curve. But anytime we have a product, there's usually going to be more than one consumer, right? Multiple people that want to purchase that good. So what we're going to do is we can look at every individual's demand curve and then come up with a market demand curve. So who did I chose one of the other one of the other models that died in a tragic gasoline fight from the movie. And if we look at both of their individual demand curves, we can get market demand by simply adding up the quantity demanded of each individual at every given price, right? So we'll look at their two demand schedules and we'll just start going at every single price, adding up each individual's quantity demanded, right? So not too tough. So we might see something like this. And we've got two individual demand curves here. So if the price was 0, what would market demand be? Well, let's assume that there's only 2 people in this economy, right? So what would the total kind of market demand be at a price of 0 here? Yeah, we're simply going to add up how much would this person consume, how much would this person consume. Now, in our economy of 2 people, there's a total of 24, right, units consumed. Or quantity demanded at the market level, right, adding up every individual, is going to be 24 if the price was 0. And then as that price changes, just like before, we're going to move to different points along our market demand curve. So we can go through at each level, we're just adding the quantities at that price, right? So we can get the market quantity demanded at all these prices. And now to come up with a demand curve for the entire market or the entire economy, well, it's the same thing we did before. It's just now we have to plot different points, right? Now I go to the Y value of 0, X value of 24, draw a dot. Y value of 1 at $1, the market demand is going to be 21. Go to the 21 the x-axis, mark that dot, right? And just go through, plot all these points, draw a line between them, and now we would have our market demand curve. So the same exact process is what we would have done with an individual. It's just that to get market quantity demanded, we have to add up every individual that's going to be in that market. Right? Any questions on this?
Do you normally plot these all on the same? Like,
so what you would want to do, I mean, you can do several things, but what we're going to probably focus on, because that's really, in the end, what we want to determine is, given the current demand in the market, how does that influence things like the price that we see of the week, right? So we're typically going to be mostly concerned with market demand, right? Market quantity demanded. But behind the scenes, we don't want to forget, and if you're thinking about like things that might change demand, well, now you have to think about, okay, there's different types of consumers, and maybe some of them, their demand curve would change if, we change the product to be a different color or, something like that. But typically, we're just going to think of, right, here's our kind of market supply and demand points at different prices. And we don't necessarily want to forget that within that are like, here was Zoolanders and here was Kens, right? So we could draw all of them if we really wanted to. We could draw like, this is a simple example, but like, you know, in the US, there are 340 million, I forget the exact number of Americans right now, but like around 300 something million people, right? Each one has an individual demand curve for something like water. We could then come up with the market demand curve by adding all of them up, but like, we don't really need to draw every single person's, right? We really are just concerned with that market demand. Any other questions on this? Okay. So I kind of just pulled out the market quantity demanded here. And like I said, we just graph it out the exact same way we're doing for individuals. It's just now we have new values for our quantity demanded. And notice I didn't go all the way to where quantity demanded is 0 here, but we could if we had more room to show more rows. Okay. All right, where are we at in time? Okay, I'll determine how I kind of go about the rest of the class. So we're okay with the demand curve. And if we look at different prices, I said, we're really looking at different prices. This is how we graph the curve. At different prices, we have different quantity demanded, right? So if you tell me the price, I can go over to the line, go down to the x-axis and tell you the quantity demanded at that price. But there could be things that change that shift the entire demand curve, other than the price of that good. So the demand curve shows us the relationship between the price changes of that specific good and how much will be consumed of it. However, there's other changes outside of just the price of a good that might influence how much is demanded. So I'm kind of thinking about, right, showing us the relationship between price and quantity demanded, all other things being held equal. So these other things, right, are the things that might be changing that could cause shifts in our demand curve, right? So anything that's going to change the entire demand curve, we kind of think about that as a shift in the demand curve. So the very first one, I kind of have a pretty crude drawing. You kind of think about if here is our original demand curve, a shift in the demand curve, something that decreases demand, would mean that at every single price, quantity demand goes down. So it's like if this is my original demand curve, at a price of $5, actually I'll use a different color. Maybe now only 1 unit is consumed. And at a price of 4, only 3 units. And at every single price, we're going to see that the quantity demanded goes down. So it's going to end up looking like this kind of leftward shift in the demand curve. And why? It's because a leftward shift represents that at every single price, quantity demanded is going down. A change in the price of a good, that just shifts where we're at on the demand curve. But a change in something other than the price of the good is going to shift the entire curve, right? So at any given price, we now see a lower quantity demand. We also have a demand increase. You can kind of imagine it works the exact opposite way, right? A demand increase means that at every single price, we're going to see quantity demanded go up, right? So a demand increase is like a movement to the right or like a shift out from like this 0, 0 point. A decrease in demand is going to be a leftward shift. We're kind of moving closer to that 0, 0 point. Okay. Kind of thinking about left and right and why, maybe another way to kind of connect with it and make sense. If I'm seeing a decrease in demand, eventually, if it shifted enough, then even at a price of 0, we would see quantity demanded be 0. So even if it was completely free, people might not want it. I think this is like the best way of this is thinking about like if something falls out of like a fad, falls out of fashion, you might see that literally they're giving them away for free and people still aren't taking it. This is like I saw this the other day at Payless. They had people went out and bought all this hand sanitizer and whatever, and didn't think about. I mean, probably made some money initially, but had these huge supplies, and then it became like people aren't really using as much. So I saw at Payless the other day, they had this huge thing set up and it was just free hand sanitizer, free bottles of hand sanitizer that they couldn't even sell for like 50 cents, so they just give them away. Right. So if you see a decrease in demand enough and you get below that 0, 0 point, well, now even if the price is 0, there's no demand, right? So that might be a good way to think about when you see a decrease in demand, it's going towards that 0, 0 point. Increases, it's kind of getting pushed away. So a couple of these things that we might see that shift the demand curve. The first one, I think it's the easiest one to think about, given what we've talked about today, is if we saw more buyers, right? So an increase in the number of buyers means that we're going to see an increase in demand, right? And that makes sense if we think about how do we come up with market demand. Come up with market demand, we just start adding up every individual's demand. So if we put 2 more individuals in here, well, now when we add all these up, we're going to be somewhere way out here, right? So just adding more consumers to a market, you're going to see an increase in demand for that product. Does that make sense? Any questions on that? If I just add more people into my economy, I'm adding up more and more quantity demand. I'm going to get a shift outward in that market demand. You got to think about if we went back here to the demand schedule, right? If I throw 2 more people in here, now I come up with market demand. I've got 12 plus 12 plus some other number plus some other. I'm just going to see a shift upward in demand. Where we at? There we are. You know, and this isn't as likely, but it is kind of occurring in some countries now because we're seeing, and regionally it happens because people move all around the country. So especially like New York and some larger cities right now, they're seeing huge decreases in demand because people are leaving their cities, right? Or at least net negative. Some people are coming, some people are going, but net, you know, the net number of people, more people are leaving than people are coming in. So if you see a decrease in population or the number of consumers, you would see a decrease in demand, right? It works kind of the exact opposite way. So yeah, this was the idea. I kind of already touched on this. We had 2 people before. If we add a 3rd or 4th person in, right, we're just going to see this shift outward. Okay? So if I add another person in, right, a 3rd person, I'm going to see an increase at every price. I'm going to have a higher quantity demand account. Okay? Any questions on any of this? Okay. So that one's pretty easy. Let's think about income, right? So this kind of gets broken down into 2 categories. So we've got an increase in income, right? What is that going to do to demand for goods? So just off like the top of your head, if you have more money, for most goods, what do you think you would probably do? You'd be willing to buy more, right? Now, maybe even if the price, like, to give you an example, I cannot justify spending, I don't know. What was the? So I actually looked into this. I reveal way too much when I teach, but I looked into getting a scooter because I was like driving around Nashville this summer. And I was using the scooters. And I was like, this would be a blast just to like get around like short places quickly. But they're like $1,500. I don't need a scooter that's going to go 15 miles per hour. Pay $1,500. If I all of a sudden win the lottery, you better believe I'm going to get a scooter. Like I'm just going to have that lying around. I might even be using it, right? But so if I have more money, we tend to see people buy more things, right? So we would say these are normal goods. Goods, pretty traditional goods, most of the common goods you think about. So new cars, computers, really food. You see an increase in consumption when people have more higher income, right? So an increase in income increases the demand curve for normal goods, right? Because now, even at the same price, I'm willing to get that scooter if I have more money than what I did, right? So the price hasn't changed at all, but simply me having more money, I'm willing to buy more of that good. Same thing I do with a new car, right? If I get enough money, I might go from buying 1 car to now I'm about to buy 2 cars, right? Price is still the same, but you know, I've got more income. Now there's some goods that we call inferior goods, where it actually works the exact opposite. When people have more money, they buy less of it, right? So it might seem counterintuitive, but and you know, you got your frame of reference is a little bit different. But I can tell you right now, when I was in college, I bought a lot more ramen than I currently do today, right? As I got more money, I stopped purchasing certain food items, right? Because I wasn't budget constrained, right? And so I was kind of substituting and switching away from those, right? So my demand for ramen, or another example, maybe really connected. My demand for Natty Light went way down, and my demand for things like Bell's and Founders beers went way up, right? So Bell's and Founders were normal, those beers were normal goods for me because when I had more money, I wanted to consume more of them. But Natty Light, when I have more money, I'm going to stop purchasing. I don't need to purchase that anymore, right? So you've got, other ideas and ramen noodles I use, but another big one is like public transportation. As people get more money, they tend to purchase cars and other modes of transportation. Whereas when you have a lower income, you see people, you have to kind of consume public transportation, right? Just based off of the level of income you have. And so we've got normal goods and inferior goods, and they kind of work in opposite directions. Okay. Any questions over this idea? This isn't too. So anytime we start to look at problems where we have income changes, we've got to think very carefully about, is this good, or we would have to be told, is this good normal good, or is it inferior? Because depending on which type of good it is, that income increase or income decrease would have very different effects. It's a paycheck, no longer drinking natty ice. Yeah. So I already prefaced my example. I forgot I had this movie. But like, this is the idea. There's some things when you have more money, you're just going to stop buying. I think I'm going to skip this slide, but I want to do one more thing before we leave. This is a much larger, those two take a little bit more time. This one should be pretty easy. I just have to mention it. So we kind of have this catch-all category. We'll talk about two other specific types of changes that we might see that influence the demand curve. But one of them is just kind of this catch-all category. So tastes and preferences, whether or not things are fads. So some examples might be like in the Atkins diet was very popular in the 90s. And so if you look at the egg consumption in the 90s, it was much higher. There was just a higher overall demand for it. And it had nothing to do with any of the other things we're going to talk about. It's just some fad at the time. You had pet rocks at one point in time, right? People were paying money to consume pet rocks. This is absurd, but it was a fad at the time, right? I guess NFTs, my example from earlier, probably fit into this category if you as far as I'm concerned. There's probably a much larger debate about that, but maybe it's like a fad or a preference. You can kind of see shifts in demand curves sometimes. Like I said, I don't want to, you don't have to spend a lot of time on this one. It's a catch-all category. When we come in class into class on Wednesday, we'll talk about two other types of demand shifters. Then we'll kind of transition into talking about supply. Okay. All right. I'll see you guys on Wednesday. Also, I have this